Just imagine if you could tell a computer exactly what you wanted to build and it just did it.
Oh.
No more, late nights debugging, no more wrestling with code.
Right.
Just pure creative energy flowing straight from your mind into like a working application.
Yeah.
I mean, we are getting closer to that reality, and today we are diving into some cutting-edge research that's really pushing the boundaries even further, wouldn't you say?
Oh, absolutely. Yeah. It's an exciting time to be working in software.
It really is.
For sure.
So the research we're looking at today is focusing on something called AceCoder.
Okay.
And it's all about making AI code generation much more accurate and reliable. Our source material today is a paper titled AceCoder, Utilizing Existing Code to Enhance Code Generation.
It's a very cool concept.
It already sounds cool, yeah.
The premise is fascinating. Basically, AceCoder doesn't try to teach AI to code from scratch.
Okay.
What it does is it takes advantage of all the massive amounts of code that's already out there.
Right.
It's like giving,
Like an apprentice.
Yeah, an AI apprentice years of on-the-job training in minutes.
That's incredible. Okay, I'm already intrigued.
Yeah.
So what's the problem that AceCoder is actually trying to solve here?
Right.
We already have AI that can generate code, right?
We do, yeah, but even the most advanced AI models, these large language models, LLMs, exactly, they often struggle with the nuances of coding.
Okay.
They might be able to generate code that at first glance looks right,
Yeah.
but it might not actually do what you want it to do, or it might be riddled with errors.
So it's kind of like asking for directions and you end up on another continent.
Exactly. Yeah.
Not exactly helpful.
Not helpful at all.
So how does AceCoder tackle this problem?
So AceCoder tries to address this by tackling two core challenges. The first is requirement understanding.
Okay.
So making sure that the AI fully grasps what you're asking it to do, not just the words, but like the intent behind the words.
Oh, so it needs to understand the goal,
Yeah.
not just the instructions.
Exactly.
How does it do that?
AceCoder uses a technique called guided code generation.
Okay.
So instead of letting the LLM just jump straight into writing code,
Right.
it first guides the AI through a series of steps to make sure it understands the problem thoroughly.
Okay, so that makes sense. It's like planning out the route before you start driving.
Exactly.
What kind of guidance are we talking about here?
So think of it like this. AceCoder acts like a very meticulous programmer.
Right.
Who starts by creating test cases.
Test cases, right?
Yes.
Every programmer's best friend and worst nightmare, all at the same time.
Exactly. But in this case, they're the AI's best friend.
Okay.
So by generating these test cases based on your instructions, AceCoder is essentially forcing the LLM to really think through all the different scenarios and all the edge cases that code needs to handle.
So it's like giving the AI a pop quiz before it takes the main exam to make sure it's really prepared.
Precisely. And the paper gives a great example of this. They gave the AI the task of removing the first and last occurrences of a character from a string.
Okay.
And standard prompting techniques, where you just feed the instructions into the AI. That often fails because they miss these tricky scenarios.
Right.
But AceCoder, by generating the test cases beforehand, was able to catch these scenarios and then actually write code that worked.
Oh, that's interesting. Okay.
Yeah.
So we've tackled challenge number one, but even if the AI understands what you want, how does it know how to actually write the code?
Right.
Because there's a million different ways to solve a problem with code, right?
Absolutely. That's the second challenge that AceCoder addresses. It's code implementation.
Okay.
And the solution is just as ingenious as the first one.
Right.
It uses something called example retrieval.
Example retrieval. Okay, break that down for me.
So it's like having a superpower search engine, but for code.
Okay.
AceCoder searches through a vast library of existing code
Right.
to find programs that solve similar problems to the one that you've given it. And it analyzes those examples, learns from them. It figures out like the best techniques, the best patterns to use.
So it's kind of like an art student studying the works of masters to pick up different techniques.
Exactly. By studying real-world examples, AceCoder learns how experienced programmers have solved similar problems in the past.
Right.
And the paper shows that this approach can lead to some remarkable results.
Okay.
For example, they gave the AI the task of finding sequences of lowercase letters joined by an underscore. And AceCoder, by searching through its library, found an example that used regular expressions.
Ooh, regular expressions.
Which, trust me, can be a bit of a headache.
Yeah, even for seasoned programmers.
Yeah, exactly.
Yeah.
So it learned how to use regular expressions effectively and was able to generate the right code.
That's impressive. It sounds like AceCoder is taking the very human approach to learning how to code, and it's working.
Yeah.
So let's talk about these libraries of existing code a little more.
Okay.
Where's they getting all this information from?
So that's one of the things that makes this research really interesting.
Okay.
They decided to use open source LLMs,
Gus.
which means that they are publicly available,
Right.
they can be replicated,
Yeah.
and built upon by other researchers.
Open source, I like it.
It also means that the libraries they used are open source code bases,
Gotcha.
which are constantly growing.
So theoretically, as more code is added,
Yes,
AceCoder gets smarter.
precisely. It's
Yep.
like having an AI apprentice that never stops learning.
Okay, so we talked about the problems that AceCoder is trying to solve.
Mhm.
The two core approaches that it uses, guided code generation
Yeah.
and example retrieval.
Yes.
But how does it actually all come together
Right.
when AceCoder is generating code?
Yeah, you're right.
Like, are there a lot of moving parts here?
It is a sophisticated system. AceCoder goes through a three-step process to generate code.
Okay.
And each step is very carefully designed to maximize both accuracy and efficiency.
Okay.
Do you want to dive into those steps?
Absolutely. Let's see how AceCoder takes an idea and turns it into actual working code.
All right, great. So the first step is...
Okay, so we left off with AceCoder's 3 steps for generating code.
Right.
I am ready to dive into the nitty-gritty, how it all works.
Yeah, perfect. Let's break those steps down.
Okay.
So step 1 is what they call example retrieval.
Okay.
So remember how we talked about AceCoder having this incredible search engine for finding relevant code examples?
Yeah, like it's searching through a giant library
Exactly.
for blueprints that might be useful
Exactly.
for the task at hand.
And it's not just grabbing any code, right?
Right.
It uses a two-pronged approach
Okay.
to make sure that it's getting the best possible examples.
Two-pronged. I like it. Tell me more.
So first, it uses a retriever to find similar programs,
Okay.
and then a selector to pick the most informative ones from that pool.
Okay, so tell me a little bit more about that retriever.
Okay, so the researchers actually made a kind of surprising choice here.
Really?
You might think they'd use some fancy AI-powered system
Right.
to analyze the code and find semantically similar examples, but
Right.
they went with a more classic technique called BM25,
BM25, okay.
which focuses on keywords and phrase matching.
Really?
Yeah.
I mean, why not something more sophisticated?
It turns out that for code, finding examples with similar keywords and structures is actually more important than finding ones with similar meaning.
That's interesting. Okay.
Yeah, think about it. Code is very precise, right? Even small changes can completely change how a program works.
It's like, yeah, if you're building a house, you need the right nails,
Exactly.
not just something nail-shaped.
Exactly.
Right.
Plus, using BM25 has another big advantage.
Okay.
It's super fast and efficient compared to those more complex AI-powered retrievers, which can be really resource-intensive.
Yeah, especially when you're dealing with huge code bases.
Especially with massive code bases.
Right, yeah.
That efficiency matters.
Okay, so BM25 finds us a bunch of potentially useful code snippets.
Yes.
But then the selector has to go in and choose the best ones.
Exactly.
How does it make those decisions?
So the selector is all about diversity.
Okay.
It wants to make sure that the AI is getting a well-rounded education.
Okay.
Right. It tries to avoid picking examples that are all very similar or that use the same techniques.
Right. So it's like building a curriculum for a coding student.
Yes.
Making sure that they're exposed to different ways of thinking and problem solving.
Exactly. And it does this by using an algorithm that considers things like keyword overlap, code length, complexity. And the result is a set of diverse and informative examples that are tailored to that task.
Perfectly curated for the job at hand.
Exactly. And that brings us to step 2, prompt construction.
Prompt construction. So we've got our hand-picked examples. What happens next?
Okay, so this is where AceCoder's guided generation approach really shines.
Okay.
So remember how we talked about it using test cases?
Yeah. To help the AI understand the problem.
Yeah, to make sure it was really learning.
Right. So in this step, those test cases become part of the prompt.
Okay.
The set of instructions given to the AI.
So instead of just giving it the problem, we're also giving it a few examples
of
how the problem should be solved.
Yes.
And some tests to make sure it's on the right track.
Precisely. And this is where things get really clever.
Okay.
The researchers found that simply including test cases alongside the examples wasn't quite enough.
Okay.
They needed a way to really integrate those tests into the learning process.
Okay, how did they do that?
So they came up with something called a preliminary.
A preliminary.
A preliminary, think of it as a set of guidelines or hints
that
help the AI connect the dots between the examples and the test cases.
Interesting.
They experimented with different types of preliminaries.
Okay.
But the one that worked best was, you guessed it, more test cases.
Wait, so we're giving it test cases before it starts?
And then more test cases as part of the instructions?
Yes.
That's a lot of tests.
It might seem like overkill.
Yeah.
But it's incredibly effective. By giving the AI these additional test cases, they're essentially forcing it to think through the problem from multiple different angles.
Okay.
It ensures a much deeper understanding.
So it's like giving it a practice exam.
Yes.
Going over the answers.
Exactly.
And then giving it another slightly harder exam.
A great analogy, and the results speak for themselves.
Yeah.
This approach significantly improves the accuracy and the quality of the code generated by the AI.
I mean, it makes sense if it's getting tested that much.
And it wasn't just about passing the tests.
Right.
The code was more robust and less prone to errors.
Okay. I'm really starting to see why AceCoder is such a big deal.
Yeah.
I mean, it's really taking this thoughtful approach to AI code generation.
It's really combining the best of human guidance with the power of machine learning.
Exactly. Which brings us to the final step, code generation.
The moment of truth.
All right. So we got our examples, our prompts, our test cases galore. What happens now?
This is where the LLM finally gets to do what it does best, write code.
Okay.
It takes all of that information, the task, the description, the examples, the test cases, that preliminary, uses it to generate the final code.
So all that prep work is really just about setting up the LLM to succeed.
Exactly. It's like giving a chef all the best ingredients, perfectly prepped and measured, so that they can create a masterpiece.
I like that. Okay.
And the results show that it works. AceCoder was able to outperform other code generation methods. Really? Even those that used much larger LLMs.
So it's not just about the size. It's about how you use it.
Exactly.
Okay.
AceCoder is proving that smarter techniques can trump brute force.
Love it. And this approach works across different LLMs.
Yeah.
Even ones that weren't trained for code generation.
That's right.
So AceCoder is tapping into something very fundamental.
It really is.
About how AI learns and solves problems.
Yeah.
Okay, before we get too carried away with all the technical details here,
all right,
I want to bring it back to our listeners.
Sure.
Why should they care about AceCoder?
Yeah.
What does this mean for the future of software?
That's a really important question, and one that I think we should dive into more in part 3.
Ooh, little cliffhanger.
Yeah.
But I think it's safe to say that AceCoder really does represent a major leap forward in AI-powered code generation.
Oh, absolutely.
So there's one more piece of the AceCoder puzzle I want to talk about.
Okay.
The human evaluation.
Yeah.
The researchers didn't just want to know if AceCoder could generate code that worked.
Right.
They wanted to know if it could generate good code.
Exact.
Code that a human would actually approve of.
Yeah, code that human developers would find valuable.
Exactly.
And this is where things get really interesting. Let's talk about what happened when they put AceCoder to the ultimate test, human scrutiny.
Welcome back to our deep dive into AceCoder.
Thanks for having me back.
We've explored how it takes existing code and uses that to generate new code.
Yeah.
It's a pretty impressive system. But the big question is, can it write code that an actual human developer would approve of?
Right.
I mean, that's where it gets really interesting.
Absolutely. Generating code that passes tests is one thing.
Right.
But writing code that's readable, maintainable, follows good coding practices, that's a whole different ballgame.
Right.
And that, for now, still requires that human touch.
So it's the difference between code that works and code that's well written.
Exactly.
How did the researchers actually test that aspect of AceCoder?
So they recruited 10 experienced developers to evaluate code generated by AceCoder and other methods.
Okay, so just like a blind taste test for code.
Exactly. The developers didn't know which system had produced which piece of code.
That makes sense. And what were they looking for specifically?
So they focused on 3 key aspects of code quality: correctness, code smell, and maintainability.
Okay, break those down for me.
So correctness is pretty straightforward. Does the code actually do what it's supposed to?
Right.
Code smell refers to bad coding practices that make the code harder to read, harder to understand, or harder to maintain. It's like a warning sign that something might be wrong, even if it technically works.
Gotcha. Okay.
And then maintainability is about how easy it is to make changes or updates to the code without breaking things.
Okay, so they wanted to see if AceCoder's code was not just functional, but elegant.
Yes.
Well-structured, easy to work with.
Yeah, like judging a piece of music on both its technical proficiency and its artistic merit.
I like that analogy. Okay, so what were the results?
The results were really impressive.
Okay.
Across all 3 categories, the developers consistently rated AceCoder's code as significantly better than code generated by other methods.
Hold on. So you're saying that AceCoder is writing code that is in some ways better than code written by humans?
That's what the results suggest.
Wow.
Yeah, and it's not just a small difference. AceCoder's code scored 61.8% higher on correctness.
Wow.
33.7% higher on code smell.
Okay.
And 13.8% higher on maintainability.
Those are the big numbers.
Those are pretty significant margins, yeah.
Yeah, so it's not just mimicking existing code, it's actually learning these underlying principles of good coding practice.
It really seems to be.
Wow, so this begs the question, if AI can now write good code, what happens to all the human programmers?
Right. Are we going to be replaced by robots?
Exactly.
That's the question a lot of people are asking, and it's a valid concern.
Yeah.
But I think it's more nuanced than just a yes or no.
Okay.
It's true that AI tools like AceCoder have the potential to automate certain aspects of coding.
Okay.
Especially those that are repetitive or routine.
Right.
But I don't think that means human programmers are going to become obsolete.
So it's more about augmenting their abilities, like giving them this super-powered assistant.
Exactly. Think of it this way. Imagine you can describe your app idea to an AI, and it generates a solid, well-structured code base for you.
Right.
That would free up human developers to focus on the more creative and strategic and high-level aspects of software development.
That's an exciting thought.
They could spend more time designing elegant solutions.
Right.
Architecting complex systems, coming up with new innovative features.
So instead of being bogged down in all the details, they can think big picture.
Exactly.
And do all the creative stuff.
It's about focusing on the things that really require human ingenuity and creativity.
Exactly. But it's not just about efficiency either, right?
Right.
AI tools like this could make software development more accessible to people who aren't experts.
Absolutely. Imagine a world where anyone with a great idea can bring it to life through software, even without knowing how to code.
I mean, that could unleash a wave of creativity.
Absolutely.
That we can only dream of.
Yeah. It's really exciting to think about.
It's really exciting, but it also raises some ethical questions, too. If AI is going to play such a big role in software development, we need to make sure that it's being used responsibly.
Absolutely. We need to think carefully about things like bias in algorithms, data privacy, the potential for misuse.
Right.
It's a complex issue with no easy answers.
Right.
But the important thing is that we're having these conversations now while the technology is still being developed.
We need to make sure we're steering it in the right direction.
Exactly.
I think we've done a pretty good job of exploring AceCoder and its implications.
I think so.
We've seen how it works, why it's a big deal.
Yeah.
We've talked about its impact on the future of programming.
It's been a great conversation.
It really has. I'm excited to see where all of this takes us in the future.
Me too. It's an amazing time to be involved in this field, and I can't wait to see what breakthroughs are coming next.
To our listeners, thank you so much for joining us on this deep dive into the world of AI code generation.
Yes, thank you.
We encourage you to keep exploring this topic, dive into the research, and engage in the conversations about the ethical and societal implications of this technology.
It's important.
The future of programming is being written right now.
It is.
And it's up to all of us to make sure it's a future that benefits everyone.
Well said.